Hello, hi everyone. Welcome to the Student the Brand. This is Evaswasa. Today topic is light refraction. Light refraction. Okay. So we'll discuss about refraction of light. Refraction of light. Well, light passing from one medium to another medium. Well, light ray is passing from one medium to another medium. The path of the light changes at the interference of the two medium. The path of the light changes at the interference of the two media is called refraction of light. Okay, so when light ray is passing from one medium to another medium, the path of the light changes at the interference of the two media is called refraction of light. Refraction of light. So here I am taking this is a rarer medium and this one is the denser medium. Rarer medium and denser medium. If the light ray is passing from rarer to denser, if the light ray is passing from rarer to denser, so at the interference of the two media, so the light ray will bend. Or the path of the light changes at the interference of the two media is called refraction of light. Is called refraction of light. Okay, so let's see here. So light ray is passing from rarer to denser. So I'm taking this a normal line. This is a normal line. So the light ray is passing from rarer to denser. Rarer to denser. So when it is passing from rarer to denser, okay. So when it is passing from rarer to denser, at the interference of the two media, it moves, it changes. So it bends towards the normal line. It bends towards the normal line. Okay. So why? The reason is, so the speed of light is decreasing in the denser medium compared to the rarer medium. Speed of light is decreasing in the denser medium. Okay. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Okay. So angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So the path of the light changes. The path of the light changes at the interference of the two media. Okay. So when it is passing from one medium to another medium, right? So I'm taking one more light ray. So if the light ray is passing from denser to rarer, it moves away from the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. Check once here. So I'm taking here like this. So this is the rarer medium and denser medium. Rarer medium and denser medium. So when the light ray is passing from denser to rarer, so the light ray moves away from the normal line. The light ray is moving away from the normal line. So here you can observe one thing. So the angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence, and angle between refracted ray and normal line is called angle of refraction. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. And here also, so this is the incident ray for this medium and this is the refracted ray. Okay. So here you can observe, now in this case, angle of incidence is greater than the angle of refraction. Angle of incidence is greater than the angle of refraction. Why? Here, when light ray is passing from rarer to denser, so in the denser medium, the light ray is moving towards the normal line, right? So if the light ray is moving towards the normal line, so the angle of refraction is decreasing, okay? Compared to the angle of incidence, the angle of refraction is less. Angle of refraction is less. And here one more thing you can see. In this case, in the second case, so angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence. Okay. So when light ray is moving from denser to rarer, if the light ray is moving from denser to rarer, so the refracted ray is moving away from the normal line. Refracted ray is moving away from the normal line. Okay. So because the speed is increasing in the rarer medium. If the light ray is moving from denser to rarer, so the speed of light is moving away from the normal. So the light ray is moving away from the normal line, speed is increasing. So light ray is moving away from the normal line, so speed is increasing the rarer medium. And here you can observe light ray is bending towards the normal line, speed is decreasing. Speed is decreasing. Understood? I hope it is very clear. I hope it is very clear. So this is about refraction and this is about refraction. Now we can see here. Now we can see. So if the light ray passing along the normal line, if the light ray is passing along the normal line, if it is passing along the normal line, so what happens? What about angle of incidence, angle of refraction and angle of deviation? So angle of incidence is 0, angle of reflection also 0. And angle of deviation is 180 degrees. Angle of deviation is 180 degrees. So angle of deviation is nothing but, so here you can see if it is passing like this. Angle of incidence, so if the light ray is passing along the normal line, if the light ray is passing along the normal line, so if you are considering here, so no refraction takes place. No refraction takes place. So if you are considering here, if the light ray is passing along the normal line, so no deviation. No deviation. The light ray moves in the same direction. Light ray moves in the same direction. Light ray moves in the same direction. So no deviation. Understood? So here angle between incident and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle between so here incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Okay. So I hope it is very clear. I hope it is very clear. Now, so now we can see. So laws of refraction. So we'll discuss about laws of refraction. Laws of refraction. Laws of refraction. So that is also known as Snell's law. Okay, laws of refraction. Laws of refraction. Laws of refraction. Laws of refraction. So point number 1. So incident ray, refracted ray, normal line lies on the same plane. Laws of refraction. Laws of refraction. Incident ray, refracted ray, normal line lies on the same plane. Point number 1. And coming to point number 2. Point number 2. So the ratio of sine of angle of incident to sine of angle of refraction equal to constant. Okay. The second one is the ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but n. That is nothing but n. So what is n here? N is the refractive index. N is the refractive index. Once again, so incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray. So here, incident ray, refracted ray, normal line lies on the same plane. So the ratio sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but n. That is nothing but n. So n is the refractive index. So n is the refractive index. What is the refractive index? So here refractive index, there are two refractive indexes are there. One is absolute refractive index, another one is relative refractive index. Absolute refractive index and relative refractive index. One is absolute refractive index, another one is relative refractive index. Okay, so first one, absolute refractive index. Absolute refractive index. Absolute refractive index. Absolute refractive index. Point number one. Absolute refractive index. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. The ratio of speed of light in vacuum by speed of light in medium. So, okay, the ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. N equal to C by V. N equal to C by V. Coming to relative refractive index. Relative refractive index. Relative refractive index is nothing but so when light rays, so I'm taking this the medium 1 and medium 2. So relative refractive index. Relative refractive index. Relative refractive index. Relative refractive index. Refractive index. Okay, so speed of light in so there relative refractive index. So what is that one? When light ray is passing from rarer to denser. When light ray is passing from rarer to denser. Okay. So refractive index of medium 2 with respect to medium 1, that is nothing but, so speed of light in medium 1 by speed of light in medium 2. Sir, why you are writing speed of light in medium 1 by speed of light in medium 2? Okay, so where you have written refractive index n2 by n1. n2 by n1. So here you can see n equal to c by v. N equal to c by v. N is inversely proportional to velocity. N is inversely proportional to velocity. So one is increasing, another one is decreasing. So that's why n is inversely proportional to velocity. So that's why n21 equal to n2 by n1, that is nothing but v1 by v2. Okay. So n2 by n1 equal to v1 by v2. n2 by n1 equal to v1 by v2. Understood or not? So this is about relative refractive index. So okay, so comparison between two mediums. But here you can see, observe here, absolute refractive index. Absolute refractive index is nothing but so speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium is called absolute refractive index. Relative refractive index is nothing but so medium, two different mediums. So one medium should not be, so other than speed of light in vacuum, you have to take different medium. Then that is relative refractive index. Okay, so other than speed of light in vacuum or air, so other than that, if you take any two medium, that is relative refractive index. So one must be speed of light in vacuum or speed of light in air or vacuum. So if it is that, with that, if you compare with another medium, that is called the absolute refractive index. Absolute refractive index is nothing but one medium must be speed of light in vacuum or air. One medium must be speed of light in vacuum or air. Vacuum or air. Another medium, speed of light in any medium. So if you are taking water or a glass or like different mediums you have to take. But one medium must be speed of light in air or vacuum. Air or vacuum. I hope it is very clear. N equal to C by V. Coming to relative refractive index, N21 equal to N2 by N1, that is nothing but V1 by V2. V1 by V2. I hope it is very clear. I hope it is very clear. Understood? Then, so next one, so we'll discuss about one more. That is so next one is, that is, so we'll discuss about glass slab, refraction through glass slab, refraction through glass slab. Let's start. If the light ray is passing from rarer to denser, it bends towards the normal line. So we know that one. If the light ray is passing from rarer to denser, it bends towards the normal line. Okay. So here you can observe. Here you can observe. So I am taking this glass slab. This is a glass slab. So I am taking like this. So light ray is passing from rarer to denser. Rarer to denser. This is a normal line. Normal line. Okay. Normal line. This is a normal line, normal line, normal line. So this is the refracted ray, and again you are taking normal line here. So this is the emergent ray, emergent ray. Understood or not? Emergent ray. So this is the initial direction of the incident ray. Okay, so initial direction, right? Yes. So now you can see the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between, okay. So angle between so this emergent ray and normal line is called angle of emergence. Angle between refracted ray and normal line is called angle of refraction. Angle between incident ray and normal line is called angle of incidence. Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. So the distance between, so this is the distance. This distance is called lateral shift. Lateral shift. Okay. So what is the lateral shift? The distance between emergent ray and initial direction of the incident ray. So the distance between emergent ray and initial direction of the incident ray is called lateral shift, or it is also called lateral displacement. Lateral shift or lateral displacement. Coming to the vertical shift. So here, so I am taking this beaker. This is the beaker. Okay. So the person is standing over here. So the coin is placed at the bottom of the beaker. Initially, he can't able to see the coin. So he can't able to see the coin. So after that, so we are pouring water. So we are pouring water. After pouring water, okay, so after filling the beaker with water, the coin position rises up. The coin position rises up. So the coin position until here. So it appears here. Okay. So this is the upper end position of the coin. Upper end position of the coin. So this is the actual position, this is the actual position, and this upper end position of the coin. So the distance between actual position to upper end position of the coin is called vertical shift. The distance between actual position to upper end position of the coin is called vertical shift. So this is the vertical shift or vertical displacement. So here you can see the distance between emergent ray and the distance between emergent ray and initial direction of the incident ray is called lateral shift or lateral displacement. Lateral shift or lateral displacement. Okay, lateral shift or lateral displacement. Okay, so now you can see coming to the vertical shift. Coming to the vertical shift. So the person is here. If you place the coin at the bottom of the beaker, initially you can't able to see. After filled water in the beaker, after pouring water, the coin position rises up. So this is the upper end position of the coin and this is the actual position of the coin. So the distance between actual position to upper end position is called vertical shift. The distance between actual position to upper end position of the coin is called vertical shift. Vertical shift. I hope it is very clear. I hope it is very clear. Understood? So again, the distance, the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Okay, so and here if you are taking, so coin is placed at the bottom of the beaker. So initially you can't able to see the coin. After pouring water, the coin position rises up. So the distance between actual position to upper end position of the coin is called vertical shift. I hope it is very clear, right? Nice. So next one. So if you are taking the beaker like this, okay. So water is filled until this position. Water is filled. So if you place the pencil, so the position of the pencil, so here it will be like this. It will be like this. Okay, so like this. Okay, so actually at the interference between water and air. Okay, so at the interference between water and air. So at this position, the pencil appears to be bent. Okay, so the pencil appears to be bent. Actually, so due to refraction, it appears like this. Okay, so due to refraction, okay, so here you can see. So I am taking like this. The position of the coil. So here it will be. So you can see at this position, you can observe here. So at the interference between water and air, at that position, so the pencil appears to be bent. At that position, the pencil appears to be bent. Okay, so at this position only. So here you can observe at this position. But actually the position is not, the pencil position is not changing due to refraction of light. So when you are seeing that one, so it appears to be bent. Due to refraction of light. So because of refraction of light, due to refraction of light, so when we are seeing through water, through the glass and water, okay, so like this, or through, if you are seeing like this, through water and air, okay, so automatically the path of the light changes. So if you are seeing from this position, okay, from this position, then what happens? So the path of the light changes when it is moving from air to water. The path of the light changes when it is moving from air to water. So that is the reason. The power. Oh, Lai Guru, thank you. So the again same. Thank you so much. Okay, again. So at this position, the path of the light changes. At this position, the path of the light changes. The path of the light changes. Understood or not? So due to refraction of light. Due to refraction of light. I hope it is very clear. I hope it is very clear. Understood? So just check once. So when light ray is passing from rarer to denser, it bends towards the normal line. So when light ray is passing from rarer to denser, it bends towards the normal line. The angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle between refracted ray and normal line is called angle between refracted ray and normal line is called angle of refraction. Angle of refraction or angle of emergence? Angle of emergence. So refracted ray normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Sorry. Okay, so angle of emergence. I hope it is very clear. So these are the points. Now we will discuss about and one more point is there, lemanoid. So if you place the lemon inside of the water, it appears bigger. If you place the lemon inside of water, it appears bigger due to refraction of light. So it appears due to refraction of light. So the lemon appears bigger when it is placed in the glass filled with water. Okay, so that's enough. And coming to the next one, one more we'll discuss. So that is, which one we will discuss? Which one? Spherical lenses. Okay, so we'll do spherical lenses. Yes, practicals now we'll see. I'll try to do it. Already few videos I uploaded related to refraction of light when it is placed. So when lemon is placed in the gas tumbler, or when a pencil is placed, like that I did a few experimental videos and uploaded. I will try. And even in the live class also I did. So I'll try once again. I will do. So in coming classes, I'll try to plan those experimental videos, like practical related videos also I'll try to plan. Otherwise, I will do and upload. So if it is not possible in the live class, so at least I will do normal videos like a shorts, then I will upload in the YouTube channel, right? Yes. So done. Clear? Now we will discuss about one more point, that is about spherical lenses. So coming to spherical lenses, so we'll see. So convex lens and concave lens. Convex lens and concave lens. Convex lens. Concave lens. Convex and concave lens. We'll discuss those points. Okay. So here you can observe this optic center F1, 2F1, F2, 2F2. Okay. So F1, 2F1, F2, 2F2. F2, 2F2. Understood? So next, so concave lens. Concave lens. Concave lens. So So you can see the concave lens. This is a concave lens. Concave lens, you can see. So this is a part, and this one also a part. And you can see this optic center, F1, 2F1, F2, 2F2. Okay, so this is about concave lens and convex lens. Concave lens and convex lens. Yeah, definitely I will teach. So definitely I will teach. So image formation by convex lens. Okay, so check once. Let's start. Right? Yes. So convex and concave lens. So now ray rules. So now we'll discuss about ray rules. Ray rules of concave lens and convex lens. Let's start. Optic center F1, 2F1, F2, 2F2. So first one, if the light ray is passing through, it is parallel to the principal axis. After refraction, passes through focus. After refraction, passing through focus. Point number 1. Coming to the next one. So optic center F1, 2F1, F2, 2F2. Light ray is passing through focus. After refraction, it will become parallel to the principal axis and moves towards infinity. Okay, so click on like button, please. So just click on like button, then it will reach to the remaining students. Okay, just click on like button. Okay, so this is second one, and coming to the third one. Optic center F1, 2F1, F2, 2F2. So light ray is passing through optic center, no deviation takes place. Okay, so no deviation takes place. So light ray is passing parallel to the principal axis. After refraction, passes through focus. Here light ray is passing through focus. After refraction, moves towards infinity. And here light ray is passing through optic center. And coming, this is a convex lens. And coming to the concave lens. So those who are watching, please do like, share and subscribe to Student in the Brand. So click on like button, share to everyone, ask your friends to join to the class. So please click on like button, then it will share to remaining students, those who want to learn, those who are in need to learn physics. Okay, so that is CBSE Grade-10 physics. So just click on like button, share to everyone. So those who are in need, ask them to join to the class. Okay, so if you are new to the channel, please do like, share and subscribe to Student the Brand. Definitely will get good content, so quality content. So if you like the content, if you like the channel, please do support the channel. Okay, so I'm considering here. So optic center F1, 2F1, F2, 2F2. So light ray is coming parallel to the principal axis. After refraction, so it moves. Okay, so you can see, and coming to the second one, so optic center F1, 2F1, F2, 2F2, light rays passing parallel. Okay, light rays passing through focus. After refraction, it will become parallel to the principal axis. And coming to the third one, so light rays passing through optic center. So optic center F1, 2F1, F2, 2F2. Light rays passing through optic center, no deviation takes place. Okay, so these are the ray rules of convex lens and concave lens. Ray rules of convex lens and concave lens. One check this ray rules. One check the ray rules. Next we'll discuss about image formations. So next we'll discuss about image formations. Okay. So image formations we'll discuss. Okay, done. So image formations by convex lens. Image formation by convex lens we'll discuss. Image formation by convex lens. So I'm taking this convex lens. So when light ray passes through, so I'm taking this convex lens. Okay. So optic center F1, 2F1, F2, 2F2. So object is at infinity. Light rays are coming from infinity. After refraction, those light rays will meet at F2. Okay. So just check once. So object is at infinity. Image is forming at F2. So one light ray I am taking like this. Another light ray I am taking like this. So after that, those light rays are meeting at F2. Okay. So image, real and inverted size of the image is highly diminished. Point number 1. Coming to point number 2. Okay, so optic center F1, 2F1, F2, 2F2. Object is placed beyond 2F1. Image will form between F2 and 2F2. Object is placed beyond 2F1. Image will form between F2 and 2F2. Okay. So I am placing object is here. So how many light rays are required? One light ray I'm taking like this, it passes through focus. Another light ray is passing through optic center. Those light rays will meet between F2 and 2F2. Between F2 and 2F2. Okay, so here you can see object is placed. So it is passing like this. So F2 and 2F2. So image will form between F2 and 2F2. Understood? So object is placed beyond 2F1. Image will form between F2 and 2F2. Object is placed beyond 2F1. Image will form between F2 and 2F2. Okay, so check once here. Object is placed beyond 2F1. Image will form between F2 and 2F2. Nature of the image is real and inverted. Size of the image is diminished. Okay, so diminished. That is the second one. Coming to the third one. So object is placed. So optic center F1, 2F1, F2 and 2F2. Understood? So here you can see okay. Okay, check once here. Object is placed at 2F1, this is F1, F2 and 2F2. So object is placed at 2F1. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? Yes. So I am taking one light ray like this. After that it passes through focus. Another light ray is passing through optic center. Those light rays will meet here at 2F2. Okay, so those light rays are meeting at 2F2. Understood? Object is placed at 2F1. Image also will form at 2F2. Nature of the image is real and inverted. Okay, so object is placed at 2F1. Image is formed at 2F2. Nature of the image is real and inverted. Size of the image is same size. Okay, so coming to the fourth one. Okay, so here you can see optic center F1, 2F1, F2, 2F2. So F1, 2F1, F2, 2F2. Understood? So object is placed between 2F1 and F1. Okay, so here how many light rays are required? One light ray I am taking like this. It passes through focus. Another light ray is passing through optic center. Those light rays will meet beyond 2F2. Okay, so the image will form beyond 2F2. So here is 2F2. Okay, so the image will form here. So object is placed between 2F1 and F1. Image will form beyond 2F2. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Okay, so these are 4 image formations. One, check these 4 image formations. So we'll discuss about remaining. So hi everyone, welcome to the class. So welcome to the class, and just check those image formations. So I'll discuss about remaining two image formations. Okay. So just check once. So these are two image formations, convex lens. Okay. So next one we'll discuss about okay, very good. So it's nice to hear revision is going on. Continue. So you can join to this class. So continuously you'll get revision, concept explanation, practice. So important questions will be discussed, important concepts will be discussed, and where we need to concentrate, where we need to focus. So all those points will discuss in the class. So inform your friends, ask your friends to join to the class, share this channel to everyone. Okay, ask your friends to join to this channel. So subscribe and ask your friends to subscribe the channel. So share as much as possible, as many as possible. So spread a one word regarding the channel. So thank you so much for doing that, and please continue the same. Thank you so much. Right. So now remaining two image formations we'll discuss. So convex lens, two image formations are there. So one is object is placed at F. One is object is placed at F. Okay, so convex image formations. Optic center F1, 2F1, F2, 2F2. So object is placed at F. Object is placed at F. Image will form at infinity. Okay. Object is placed at F. So here object is placed. So one light I am taking like this. It passes through focus. Okay. Another light is passing through optic center. So another light ray passing through optic center. You can see object is at F. Image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Size of the image is highly enlarged. So thank you so much. So happy to hear. So please do like, share and subscribe. So that is great help to me. Share to your friends. Those who like the video, those who like the channel, those who like my explanation, please spread a one word regarding the channel. Inform to everyone. Okay, so I am doing so much hard work. Okay, so I am putting lot of efforts. So make the channel to reach everyone. So make that efforts to be useful. So convert those efforts into results. Okay, so it will be in your hands only. So this is a light reflection and diffraction chapter, CBSE Grade 10 Physics. Those who are studying in CBSE Grade 10 Physics, please involve, join to the class. Definitely good content will be there, quality content will be there. So explanation of chapters will be going on. Okay, so important questions will be discussed, important concepts will be discussed, and where we need to practice, where we have to focus, those points also I will give. And how to write, okay, so particular question, how many marks will get for writing this type of question, like that everything I'll give. Important topics, important concepts I'll be giving in the class. So I need one help from you all, that is, so just do like, share and subscribe. Okay, so and share one word regarding my channel to everyone, those who are studying. So not only 10th class, remaining 6th, 7th, 8th, those who are studying in right from 6th to 12th. Okay, so spread the one word regarding the channel. So that is only one thing, one help I want you from you all. So please spread a one word, inform to everyone. So my efforts should not go like that unused. So it must be helpful to the students, it must be helpful to the students, it must be useful to the students. So my hard work must be converted into fruitful results. So I want that. So my content must be useful to the students. Okay, so please do like, share and subscribe and spread one word. So until this time I'm working means, so you can understand how much efforts I'm keeping towards to deliver the content. Okay, so please do this help and share one word regarding the channel to everyone. Okay, so please do like. So do hard work. Okay, so whatever it happens, whatever the situation it is, so you can understand right from. So I can able to say my hard work, so that is a great motivation to everyone. So whatever the situations, whatever the hurdles you are facing, okay, so definitely one day you'll get results. One day, if you are thinking about only result, okay, so I'm not getting result, I'm not getting result. If you are keeping thinking about it, okay, so you keep on thinking about the result, so it is not possible to get motivated. Okay, so you'll go to demotivated. Okay, my god, so I'm doing a lot of hard work, I'm not getting results. So I'm doing so much hard work, but I'm not getting results. So I did lot of hard work. See, success will not come easily. Okay, now if it is coming easily, it goes easily only. So if you put lot of efforts to achieve that, definitely it stays with you. Okay, na? Success will stay with you, right? So you have to put your efforts to get the success. Okay, so do hard work, do hard work. Okay, so do hard work, do hard work, concentrate on your work improvement. At least every day. So one drop, okay, improve yourself. One drop you can improve yourself. One you can say 1 point you can improve yourself. 1% you can improve yourself. Definitely one day you'll achieve your goal. Okay, one day you'll achieve your goal. So you're doing hard work, but if you're not getting result means, so it's so some time is required to achieve success. Okay, so for everyone there is a clock. Okay, for everyone there is a time. So the time is waiting for you. So you should be in the race, you should be in the path. Okay, so get motivation. So do hard work. Only do work, that's enough. Only do work. Do your work, do your work. Work. No result, no problem. Again, work. No result, still no problem. Work. Again, you are not getting result, no problem at all. So get up and do work with little improvement every day. Okay, so you keep on doing, you're not getting results, but you have to check yourself where I am lagging, how to rectify it, how to rectify this one. Okay, so how we have to plan, how we have to achieve the success, what are the ways to get the success. So you have to check every day. You have to check yourself first. Okay, so you have to check yourself how best you can deliver, how best you can put your efforts to get the success. So think about that one. Okay, think about that one. That's enough. That's enough. So improve yourself every day, 1% at a time. Okay, at a time you can't no change suddenly, right? So overnight you can't change everything. Okay, so it's not good for us, it's not good also. So what you have to do, you have to improve yourself. Okay, so keep confident, believe yourself, believe yourself, that's enough. Whatever it happens, whatever things goes on, so believe yourself, do hard work, stay motivated, be consistent, put your efforts, that's enough. Definitely you will achieve success. Understood? You will achieve success, that's enough. Okay, so thank you so much for joining and attending and listening. So those who are attending the class, those who are there in the live, please do like, share, and spread one word regarding the channel. Inform your friends. So those who are studying, so right from 6 to 12, those are writing JE NEET and also JE and NEET. Okay, so those are writing for competitive exams also. So inform to everyone, ask your friends to join to the class, share one word regarding the channel. That is what I want from you all. Okay, so this is about the last one I will do. So we'll wind up this class today. So I'm taking the convex lens. This is the optic center, f1, 2f1, f2, 2f2. Object is placed between f1 and o. So object is placed between f1 and o. Okay, so one light ray is passing through focus, another light ray is passing through optic center. If you are extending those light rays will meet at one point. So the image will form here. So object is placed between F and O. Image will form same side of the object, same side of the object. Nature of the image is virtual, erect, and enlarge. Compared to the object, image size is increased. Okay. So thank you so much for joining, attending, listening, and so supporting. Please do encourage the channel. Please do support the channel. Inform to your friends. Ask your friends to join to the class. Spread one word regarding the channel. So thank you so much. We'll see you in the next class. So see you soon. Thank you.